Okay, yo, let's start. So yesterday we were in the process of implementing the water solver, and we were doing the second step of it, and the result of that second step actually surprised me, both in speed and result. And I was starting to think that maybe it could even be enough to stop around here. But let's see what we have. So if I add, although that depends on how loose we are with height differences when it comes to water, because if we add the maximum amount of water here, we get something like this. And let's see here, blue cubes are related to the first step of the algorithm, so you can ignore that one. Red one is related to the second step of the algorithm, and the idea then would be to transform this red one into water, a water mesh basically. But there's a few problems I want to take a look at still. And the gray cubes we can see here flickering are edges, so they're just gonna help make the mesh creation a little bit easier, or mesh distortion. So in most places it's okay. I would say, we would get a pool of water here. Some sort of waterfall down here, flow of water here going in this river here. I mean, it's okay. Maybe not the best, but it's okay. And if we do, let's just add half the amount of water. So 0.5 here. Then we get something like this. And so blue boxes, first step of algorithm, that's not going to be water. The red is, however, going to be water. So we get a little pool of water here. We get a pool of water here. We get a big pool of water here flowing down here. I mean, this is acceptable, although I still have a few small problems with it, but let's see. 0.7. Ooh. 0.7 even gives us this one right here. Ah, okay. Definitely not too bad. But then if we do 0.8, we get something like this. So an overflowing pool of water here. I guess this would actually be okay. You have a tiny flow of water running down here. Actually enough for it to walk over here. I guess it depends all of how we render it, but this would probably also be okay. The only thing that bothers me, or the thing that bothers me the most, is the difference we can see here between water on the same height actually. So if we have a pool of water like this, I don't want the middle to be higher than the edges. Although I guess that would be sort of okay. But then let's try this. I'm gonna open up the original or the terrain texture, and we can see if we can add some additional or I want to add one additional very big pit, I would say. Let's set it over here. We're gonna add one of those, and we're gonna add one of those. So what do we have? So for instance, if we add 0.1 water here, we get something like this. We get a little bit of a puddle. That's good because we don't add too much water. So let's go 3, 5, 1. Yeah, this is what I want to avoid. And it's related to let's see here. When we walk, yeah, we have a building graphs base cost range. We have a minimum cost of 0.02 walking parallel. And that's what we want to, that's what gives this kind of result. But although if we change that one to 0, just plainly change it to 0, this one might walk on forever. So we need to keep track of, yeah, we need to add some more checks basically, or multiply it with some additional information. And that is going to be one could think that we can do, when we're far enough from the minima point, that's when we start adding a negative value of moving in parallel, but could probably lead to some problems in this case. But I think it's something like that we need to introduce. This one, for instance, would be or if we start adding it for if we're far enough from the minima and the height of the one we're currently adding is bigger than the minima, I'm gonna do this first of all. I want to make it a little bit easier to test, so we're gonna do fluid solver. I think we're gonna reset it between uses. What was it? Many. Select many. How do we... Oh. Values are matrices. So do we want to do... Oh yeah, when it came to those, we did something like... What was it? Flatten box array. Flatten many works on jagged, but yeah, we had this answer a few days ago. There we go. $58. Ooh, that is true. Like if we take a look at this one, this is the minima we get. We get edges here. That's weird though. No, it's not. I think we could work pretty nicely with that. Let's see though. Yeah, it would look pretty good. Yeah, the only thing that bothers me is that we get a little bit of a peak at the minima, so we need to figure that one out. But other than that... Beautiful. Get an edge here. Yeah, it's still a little bit of a problem knowing which one of these to run first, which one reaches the other one first. But we're gonna take care of that problem after we have fixed the obvious high point. See here. I wonder if there is some very clean, nice solution to it. So when it comes to the algorithm, we choose let's see. Order by descending. Yeah, like we could probably introduce yeah, if we just introduce some more information, like this is building graphs fluid amount, but then we also have a actual fluid amount. Ah, of course. So we have a building graphs fluid amount, and this one ends after a certain after we, like this one decreases over distance, both upwards and downwards and parallel. Maybe not downwards, we'll see. But then we have an actual fluid amount that doesn't decrease when going parallel. But yo, what's up, Harry? I'm good. Thank you for asking. How about you? I think yesterday was... we made some very nice progress yesterday. The only problem I can think of having two separate fluids is we need to know when we reach an end because the ground is too big, or like there's an edge, and we need to know when we reach the end because we're out of fluid, basically. So then again, yo, what's up, Cooler SK? It's the morning for me. What is it for you? It's the morning for me as well, or 9:30, I think. Yup. It would be very nice to have two fluid amounts to work with here. Although I'm wondering how the distinct, so when we reach an end, I would love to be able to avoid having to loop through all the fluid points again. Or walk through it again, but maybe that's the only thing we can do. Yeah, we could pretty easily fix this, I think, by we mark points if they end because they can't move in that direction because of okay, we could that work? Let's say that we have this result, and the ones at the edges, they are marked as they stopped because, or this one stopped because, not because the fluid ran out, well it did, but it ran out because the height was bigger. Okay, so if we mark them, this is an edge because we moved upwards. Let's see, let's do this example. This is an edge because we moved upwards. This is an edge because we moved parallel to the ground. Fuck, we could probably fix this overflow as well. Okay, so if we get all the edges, but we don't have an edge here. If we moved backwards from edges, it would probably be... I think we could do something smart here. Just go south to Finland and knock on the City Skylines studio and ask them how they did their water. Yeah, maybe I should. The blue boxes are the first iteration of the algorithm. Basically, its only job is to find the yellow boxes, and yellow boxes are minimas. Points yeah, the yellow are the minimas, and the red one is the second iteration of the algorithm, which uses information from the first. And currently red is what we will convert to water. Does cities skylines filter? Doesn't they just use a plain solution? It looks like it. Can they support? Do they support different heights of the water? Ah, beautiful. I might check it out. I have it on my list, you know. Time is the only thing I lack. Oh, that's beautiful. That is beautiful. Okay, I think we can fix this pretty nicely. Okay, hear me out. I'm thinking we should probably these edges do really tell us a lot, though. But I wonder. It all comes down to, do I want to support water that looks like this? It's a bit too weird, I think. But if we work with edges, I want to do this. Let's see. Let's do this for now. Yeah, I don't remember if this what engine the second one uses. Oh, do we? Oh yeah, we want to do... while and remove. Here we find the minimas. Kurosuke, I was worried what would happen with second game, especially when they released the first trailer. I was actually pretty pumped for the second game. Did not play the first, however. But damn, it got a lot of flack on release. For being pretty unperformant, right? Okay, so I'm thinking, let's see here. Yeah. If we take the minima with the most fluid and we start building a graph from it, but we make sure that the fluid amount is less than its neighbors. That won't work. Will work in this case, not in this one. Or actually it will. It won't. Let's see. Or United Blade, what's up? Kurosuke, the first trailer had literally zero gameplay in it. Just pre-rendered videos of pretty cityscapes. Oh yeah, I remember that. I remember that trailer. If we keep track of number of steps from minima, yeah, then we can yes, let's see here. I think it's pretty straightforward to make it nice if one problem can be solved, and that is when the decision of starting to remove water amount can be decided. Like if we would allow it for going on forever, then we could figure out the edges and such pretty nicely. But I don't want that. One sec though. What the fuck? If we take each minima, just like we do, and from that minima we start walking outwards, and as soon as... if we walk in a direction... if we walk in a direction that is downwards, then we stop. If we walk parallel, or upwards, we continue. If we find another minima, yeah, that's what we want to do. Let's see. And then of course game releases and it's literally the same thing as the first game. Didn't they introduce a couple of new features though? Yeah, but yeah, with worse performance. Yeah, I think we could pretty easily find... Like, we could locate the minimas, and then we could find what area they cover, and the maximum amount of water they support. The question, can we use that to something nice? For something nice, rather. The only differences were quality of life features. Season changes though. That's pretty nice. Okay, but yeah, the second part not so nice. Okay, we can pretty easily find the maximum amount of water in a minima, supported by a minima. And if we move downwards, then we stop. Whoa, 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 whoa. Okay, this algorithm finds all minimas, and what we do then is we calculate the maximum amount of water one of those minimas can have. But yeah, we have to make sure that we don't wander too far. Yeah, we want to make sure that we don't wander too far. But what would we have in the end? We would have minimas. With the max amount of water they can have. And Hmm. We would probably... This would look pretty weird, I would say. Maybe it's okay. Harry, is this the hardest thing you've done so far? Of all software things I've done, no, I don't think so. But in this game, it's in the top at least. It's in the top. But like, it's hard in a fun way. It's not hard in like I can't find any solution out of it. It's hard in a way like I see these multiple different approaches we can take, but we have to figure out if they're viable, which one is best, and so things. Oh, no problem. No problem at all. I think... No, this is not the hardest. I think the apparel system and clipping is the hardest thing. We have not solved it entirely still. Yeah, that one is probably the hardest part, because it was hard seeing solutions forward. Like here I see multiple solutions we can try. I just have to go over them and see, like, will they yield a result I would be happy with. Okay, it's probably... To find the area of a minima, we could probably do... Yeah, if we go upwards and then parallel or down, that's part of the minima area. if we just go Rocka still have ways to go to extend grass making, which lasted several months. I don't think it was that bad, was it? 1 month for the shader and a half a month for the grass terraforming, wasn't it? And Harry, it still amazes me that some code can transform some words and formulas and can make this. Actually, it still amazes me as well. That's the beauty of it. It's insane. I wonder if that was one of the biggest hurdles I had to go through in my programming career. Learning how to take a real life problem, specifying in such a way, specifying it in an implementable way, and then implement it. Like that middle step there. Computers indeed, they are insane. Yeah, I know how we could find the area of a minima. The only thing I'm wondering is, would that actually help us? Because I still want rivers. I still want rivers. We want to fill, but we want to add... Oh. Specifying the end. I'm trying to solve this but also avoid. We don't want a never-ending algorithm basically. Yeah, Harry, soon I might. Cooler SK back in school days when I was on the regional computer graphics competition. Nice. What did you say, Cooler SK? Do you remember? Or didn't you say anything at all? What's up, Prosto? Wait, maybe I'm not thinking about this. Maybe we should. Let's see here. I want to check if we add this one back. Let's just introduce more steps. What the fuck? Okay, this one is great. One sec, why are we getting such a good result from this one now? Yeah, that's more like it. Okay. If such a beautiful result. What I want to avoid here is this one. We never want a minima we take to overflow. So before we start walking, we might want to figure out what the maximum amount of water allowed in this one is. And how can we do that? Yeah, okay, we don't want it to overflow. This one is okay though. So the problem when we get something like this, it's because this minima overflowed, right? But if we can... So when we have this, if we go through each minima... If we go through each minima and we calculate the maximum amount of water for that one, that should be pretty easy. We just want to walk We want to continue walking while we don't find until we find something that moves downwards, either upwards and in parallel or downwards. Fuck yeah. That should be pretty easy. Then this one wouldn't overflow. Downwards, upwards and in parallel. I want to see what kind of result we can get from that. So we find all minimas, and then we take each minima. We take the minima with the most amount of fluid, and we start walking. We find the maximum amount of fluid allowed for that one, and when we have that, we start filling it up. That's when we start the graphs. Okay, I think we got this. Well, they asked what I like about computers, and after contemplating nervously for a moment, went everything. That's a good answer, I would say. But I feel with Kid U, I do. And Prosto, what is that? If you're referring to this, we're working on a water terraforming system. So the character or the player will be able to add water to this terrain in such a way that lakes and rivers and stuff like that can be created. Low FPS as well, I wonder. I wonder what's the cost for it. Oh well. And the reason why no one does it in games. I think we can reach a nice solution. I really do. Yeah, okay, so for each of these minimas, the yellow ones, we're gonna take the one with the most fluid and we're gonna walk and find we're gonna find what's the most amount of fluid we can add to that one, because I don't want this. I don't want, what the hell? I don't want this, so this is what we want to try and avoid. But it would be fixed before we do this red iteration. We take this minima and find the most amount of fluid we can add to it. And if we move in up or down and then in parallel we stop. I just have to... Harry, how many people are working on this? Are we talking about this game or fluid simulation? I saw realistic voxel pressure-based fluid simulation about 10 years ago, but more like a concept. Yeah, I'm a big fan of those. a while back I actually implemented a two-dimensional it is a fluid simulation as well. It is basically Joe Stamp's fluid simulation, but that's one of the biggest problems, I would say, with what we're trying to do here as well. We don't want it to be realistic. We have a set of rules that are very specific for our use case, which discards most, if not all, the solutions you can find online, unfortunately. Harry the game. Currently just me. So 1. Terraria have it. Never played, unfortunately. Been eyeing that game for a while though. And it's in 2 dimension as well. Makes it a little bit easier. It's very pixel based as well, right? Yeah, we're gonna transform these voxels into a mesh later on. Team capacity is 1 Rockadoodle. Yes, indeed. Fuck, will it work? It will work. But how do I want to implement this? Yeah, we're gonna add... I have a few finished ones here, but I want to let's just keep it like this. I want to do iteration 3. Like, we can still go back to this one. We have only done step 1 and step 2, but I want to add iteration 4, and I want to name it something extremely cool. Oh yeah. Terraria is tile based. You're definitely correct, I think. Thank you, Harry. Appreciate it. Yeah, we're pretty far from 9 years so far. I would be quite depressed if this was 9 years, I think. I think in October it will be 3 years since I wrote the first line of code for this project. But the first year or 2 years I didn't develop it as actively as I've done since the beginning of this year. So the idea is to... I don't want to specify too much, but the idea is that early next year we will have the Terraform vertical slice in place. So pretty much how the gameplay will look when it comes to terraforming. The first half year of next year, I hope. Cooler SK still waiting for that tower defense game. Are you serious? I released it and discontinued it. I think it was released for a couple of years. Okay. Probably want to rename this one later on. And the thing with this one is that we want to do the first step here as well. This one is great. And we want to do two for each reachable minima. Calculate for each reachable minima. For each reachable minima, calculate. We're gonna do it like this. Let's write this one the correct way from the start. For each reachable minima, calculate the maximum allowed fluid although, let's see here. How the fuck will it look here? This one will work because of this one. Ah, fuck, it's not as easy as I first expected. If we move upwards and then parallel or down, we want to stop. But could we also have this? Then we will find all of this. But could we have a case where we don't want if we move upwards and then parallel or down, then we stop. But could that mean, yeah, we find a minima, so we shouldn't be able to move in parallel forever. But if we move down, down. Yeah, wouldn't that make sense? So for each minima, we calculate the area it can cover. We stop if we move up and then down or in parallel. But then we have to mark something as up. Oops. I think we can do that. Calculate the maximum allowed fluid at minima without overflowing. CoolerSK, also what happened to the dungeon generation project? Yeah, that one got binned. Calculate the maximum allowed fluid at minima without overflowing. Walk, or we're gonna do like this. Nah, I wanna. For each reachable minima, we're gonna do like this. Yeah. For each reachable minima, calculate the maximum allowed fluid without it overflowing. Sort reachable minimas based on fluid amount for each minima visit add neighbors or for each neighbor in I wonder if we want to do this. Can we do this? Yeah, we want to check. Yeah, CoolerSK, I think we're gonna start basic. If we traverse every neighbor, but we stop if we go up and then parallel or down, at this point it would leave us with here, but we want it to be able to overflow. What's up, Road Pattinson? We want it to be able to overflow downwards. One sec. Oh, this is beautiful. This is not. Actually. If we take this. Okay. If we take this result and then we check this one. This one we don't. Fuck, we spread that one to this direction. That is true. Ooh, this is a weird edge we get here. It's probably just old. Yeah, it's old. Could it be? This is fucked. Yeah, the edge one we might need to fix the edge finder. What parent would call his son Dudley? Good question. I think I've only heard it in fiction. What about this? Let's see if... Yeah, for this one, for instance... Okay, I would like to define it like this. We have points that either stop spreading because they're locked in, or we have points that stop spreading because they disperse. The water amount runs out, basically. We have this information. We can get that information quite easily. This one disperses, this one disperses, this one disperses. Yeah, so if this one If this one has a higher height than the minima it comes from, then we remove it. We do so for this, this. Yeah, we could find all points that this, we could do it like the worst performant way. We get all points that disperse because they run out of water. And then we check, is the height of those bigger than the height of the minima? If so, we run the algorithm with that as a minima. What will happen here? Yes. Fuck, I think we can do it like that. I want to try it real quick. So this one disperses because we're moving in parallel, we run out of water. So then we take the height of this one. We take the height of this one. Or if we take all of those points, we sort them based on lowest height. We take all those, but we only add them if they have a height that is bigger than this one. And then we sort them, so we take the one with the smallest height. And then we set the fluid level to that here. I want to try this. So for instance, if we wouldn't have enough water to here, it disperses here, but the fluid amount here, or the height of the terrain here, is less than this one here, then it's okay. Ooh, how would it look here? I want to try it, I think. We don't have any disperse here, so... yes. None here. This... might... but I wonder... Now we want to do it here as well. We're gonna try some different things. I think we can make this work. I just wonder how I want to handle it if we move downwards and disperse. Yeah, I want to try it. Thank you, Harry, by the way, if you're still here. Thank you for dropping by. Kenny runs a game jam. Oh, nice. I want to do a game jam so bad. The plan was to do the previous Ludum Dairy, as I've said. But I think if my schedule lines up, I think I'm going to do the GMTK one this year. I used to do a lot of game jams. Do 16 hours streams and just fucking grind that game out. Would love it. Yeah, I think that's how we're gonna do. We're gonna find every point where this one disperses. If the height of that point is higher than this one, then we limit the amount. But I just want to write this down. We're gonna write it real quick. For each Rulema, calculate the maximum allowed fluid without overflowing. For each, or so it's going to be sort reachable minimas m based on fluid amount. For each fill out, let's see here, for each minima fuck, why do I have such a hard time? Add m, let's see here, for each m in m, add m to unvisited nodes. For each node p in p for each neighbor, calculate new water amount by traversing from p. I mean neighbor, yeah, we pretty much want to do this again. I don't see your itch link. That's true. I think my name on itch is just Rockadoodle as well. And I think I have a few of them. I never won a game jam, however. Okay, so I've finished 1, 2, 3, 4, 5, 6 game jams, I think. Although this one is probably the one I'm happiest with of all my game jams. I think this one and this one are playable, and this one are playable in the web browser. Wonder if it's still playable though. It's pretty much just a simplified version of Overcooked, I would say. Pretty nice. Yeah, that's about it. Let's see. Yeah, where were we? Here. For each node P in P, yes. For each neighbor N of P, calculate new water amount. Yes, we want to do that. And then we want to do, if we is bigger than current water amount in neighbor, yes. But we want to do else if v is 0 and n has a higher, or let's see here, has a is 0 and n has a bigger height than P, add n to create empty list of let's see here. What do I want to call it? Unvalid end points u. Add n to unvalid end point, or actually to u. And then we do this. One, two, three, four. Sort u on sort u. Do I want to do descending, or we want to get the ascending? add and then we want to do this again. Yeah, it's rough as fuck, but I think it might work. Because now we have figured out, I think, how much fluid we can add without it overflowing in the wrong way. So now we can add real water, like the real amount of water to the minima. Now we can add the real amount of water to the minima and let it flow in the graph, basically. We want to build a graph again. Yeah, I think so. What's up, Abby the Lesbiab? Thank you for the raid, appreciate it. And I hope you had a wonderful stream. Yeah, I want to do more before we end this step. I want to do a few more things. So now when we have the correct amount, let's see here. But yeah, we had a good stream working on a Twitch RPG. Oh, a lot of people actually do. Maybe not RPG, but Twitch integrated games. Very interesting to me. Okay, add fluid F2M add fluid F to M where F is equal to, how the hell do I want to do this? Where fluid amount is equal to we want to do it like this, is equal to U0. Can we do double here? I don't think so. I'm heading to bed though. Have a good stream. Thank you, appreciate it, and thank you once again for the raid. To M where F, we need to calculate this fluid based on U0, so the first one we have after ascend sort. But we want to take the height. I don't know how to mark this if we can't do... Maybe we can. Oh, yeah. Ah. Double subscripts use braces to clarify. Do we need to do it like this then? Ooh. No. I think we can do it like... Can we do it like this? Oh, beautiful, beautiful. Where F... so the height of this one... I think this is... Yeah. And we want to take... So the height of this one is bigger than P. So we want to take this one minus P. We don't want to do that. Minus P height. Add fluid F to M or F to that. For each node P minimum based fill. For each node P in let's see here. Add M add M to unvisited nodes. For each neighbor, calculate new water amount by traversing from P if P is bigger than current water amount in neighbor. Set in neighbor to P if it doesn't already contain it. We don't want to do this one here. So at the end of this one, let's see here. Ooh. And then when we have this, create final graph list. One, two, three. 1, 2, 3, 4. Add P to G. One, two, three, four, like this. for each P in G, remove P from M. What a mess. So basically, initially we find all minimas based on a very aggressive water fill. We basically just want to find, do we have any points in our terrain where water can collect? If we don't, we quit. If we do, that's when we want to start filling the water. So we take all these reachable minimas, we sort them based on fluid amount calculated by this one, and then for each minima we add M minima to unvisited nodes, and then we create a list that is invalid endpoints. For each node P in P, so in unvisited nodes, we fill all neighbors based on some calculations. Yeah, and then we add neighbor to unvisited nodes. If we don't succeed in filling the water, it's either because we don't have enough water to climb upwards, or we don't have enough water to climb in parallel. And if we don't have enough water to climb in parallel, that means that the water has dispersed in the air, I guess. If so, we add it to U, but we only add it to U if the dispersion node has a height that is bigger than P. That is not entirely true. Let's see. If it has a bigger height than M. Because that means that the minima overflows in such a way that it leads to a point where the water just dries up. So we want to fix that. M. No. Height than M. If so, we add it to U, which is unvalid endpoint. Yes. And here we add to P, so we will continue with this one. When we're done with all that, we have a list of unvalid endpoints. So we sort unvalid endpoints in such a way so we get the one with the smallest height. So remember, this is an endpoint that has a height that is bigger than M, but it is the smallest one of all of those points. So then we calculate a new fluid amount. We take the height of that one and we make it impossible to reach that one. So the fluid amount shouldn't be that big so we can reach that point. Then we create a final graph list. We add M to unvisited nodes P. This one is empty from this one, so we can add it again. And then we do a similar for loop. So now we try to fill it once again, but with the final water amount. So we just do this. Remember, transfer from P. And then we set it in neighbor. Add neighbor to unvisited node if it doesn't already contain it. We just add it if we get water to that point. And for each point here, we also add it to the graph. So each point that actually gets water, That's not entirely true. We also add... I think we're going to start with this. We don't care about the edges just yet. So if we fill it with water, we add it to the graph. And then the last thing we want to do is, for each final point in the graph, we want to remove them from minimas, because that means that a minima here has already been assigned fluid from a minima in its close, from another minima that can reach it. I'm a little bit, I don't know exactly how we're gonna sort this, like if this is the correct sort we want to do, but we will find out. I think this should work. This should lead to a result that will fill up a minima, but we don't fill it up in such a way that it can overflow and disperse, but we fill it up in such a way that it can flow downwards and disperse. Downward dispersion okay, upward dispersion not okay. That would leave the final algorithm to look like this. We already have this one in place, so we're just going to take this one. Yeah. Minima based fill. Yeah, we're probably going to find some issues with this one. Hopefully not unsolvable issues, though. What happened here? Fuck. Ah. Didn't this work previously? Ah, fuck it, let's do it like... no. Whoa, we can do... whatever, let's go with that. So we already have this in place, so let's do... Fluid solver mode. Minima. We're gonna rename it. Minima threshold fill. What do we call these? What can we do? And let's see, I want to copy we can probably keep this one on one line for now. Instantiate and fluid points, possible minimas, then we just do it like this. I want to try this one. We spawn fluid visualization objects. Yeah, let's try this. Add fluid minima threshold fill. Beautiful. Okay, and then I want to do, I'm going to do it like this. Step duration. we're gonna rename this one to small step duration, or big step duration. And we do, so when part 1 is done, if big step duration is bigger than 0, yield return new and then we do algorithm step 2. Calculate correct fluid amount per minima, or calculate non-overflow fluid amount per minima. Sort reachable minimas based on fluid amount. I wonder. I wonder if I want to split this one into 2 steps. Let's just implement it like this, see what we get. Sort reachable minimas based on fluid amount. We already do that here. Or actually, while possible, nah, that's not true. At the end of this one we should have minimas. Minimas is equal to minimas dot order by descending m. And what we fill here is finding minimas fluid. Although I'm not sure this one is the correct one. This one. Experiment with different sorting. What is the word I'm looking for? Not the correct word, but whatever. Good morning, Dasai. For each m in M, yes, we want to do while minimas dot count bigger than 0. Let's see here. Possible minimas. Unvisited nodes. So while this one has a count bigger than 0, we continue. So when we're here, it has a count of 0. So we want to do unvisited nodes dot add fluid point m is equal to minimas dot first, and then we do minimas remove at 0. Then we add m here. While unvisited nodes dot count is bigger than 0. Create empty list of yeah, we want to do that here. Unvalid, isn't it invalid? I think it is. Nodes or end nodes. Okay, so while unvisited nodes speed at 0, then we want to do for each neighbor, calculate new water amount, we want to do this, and then we want to do for each in here, yes. So for every neighbor, fluid points, calculate fluid amount, and here we do finding minimus error. That's not what we want to use. We want to do building graphs error. Get neighbors, calculate height, finding one step we missed, or I missed. Add building graphs fluid. Yes. So building graphs error margin, building graphs wait. Oh, let's see. Do we want to do this still? Maybe we do. Add new fluid amount, building graphs error margin, unvisited no. Yeah, we want to skip that. Okay. So now we pretty much do this. Set v in neighbor. Add n to p if it doesn't already contain it. Yeah, we want to take this one. Okay, else if. So this is where we want to figure out, yeah, if new water amount is 0. Let's see here, new fluid amount. Else if new fluid amount is less than or equal to 0. And we want to do something cool. Although I wonder, we probably want to do if new fluid amount plus error margin. Nah, if we get to this point, we're gonna leave it like this. But, and n has a bigger height than m, so we also want to check and n dot height is error margin minus building graphs error margin is less than m dot height nah, I think, but we're gonna add okay, if this is true, we want to add n to u, but we don't want to add it multiple times. We might as well invalid n nodes. But here we also have something I want to check. If invalid n nodes contains n, remove n. So if we have reached this point previously and we marked it as an invalid n node, this will make sure that we make the invalid n node valid. If we might be reaching it from a different direction this time around. Yeah. So at this point, after this one, now we have a set of invalid n nodes. So now we want to sort them, and we want to sort them based on height, ascend sort. So invalid n nodes is equal to sort or order by, this is ascending, I or e dot height I think we're also going to do algorithm step 2.1, calculate invalid end graph nodes. Algorithm step 2.2. Get worse end node. One sec. Yeah. Or actually calculate real fluid amount for minima. Invalid end nodes. Sort, then we calculate float fluid amount. Do we already have that one? No. Is equal to I'm pretty sure it's in this step we're actually going to add the fluid to the texture as well. But let's see here. So worst height minus p height. No. Although I wonder, am I over? What do we have? Should be okay. But we actually want to do M here. So fluid amount is equal to invalid end nodes we're going to do this. Fluid amount is equal to m dot building graphs fluid amount, and then we check if invalid end nodes dot count is bigger than 0, because we might actually get to a case where we have none like that. Although, one sec. I think we can do like this. So if then we will recalculate fluid amounts, invalid end nodes dot first dot height minus m height. Beautiful. Final fluid amount, and this is where we're going to do the last step, and it's create final graph list G. final fluid amount. So what we want to do here is fluid point and here we finally want to do terrain patch dot set terrain data dot set raw fluid amount x y fluid amount. So what do we want to do here? Create final graph list G, list fluid point graph. Oh, one sec. This is not entirely true. We need to check one more thing. No, we don't. I don't think. I will see how it goes. Create final graph list, add M to unvisited nodes. If it doesn't contain it added, we don't care about this for now. Else if we don't care about this. So then we do this, and once we have fixed it, let's see here. We also want to do if graph, if it doesn't contain n. Is it? If graph doesn't contain p, add p. So then we have built up the graph, and the final thing we want to do here is algorithm step 2.4, remove already visited minimas. And that's basically, we have done this, we have done this, we have done this. At P to G, at this one we want to at P to G, for each P in G, remove P from M. So basically, don't we have union or something like that? Let's just do minimas fluid minimas dot remove p. And here we remove hopefully a lot from minimas, which means like first of all we remove the first one here, but then we remove affected minimas. This one should reach 0, and I think we're done. But before I try it, I want to add some visuals to it. I want to add some extra delays on it, and yeah, but before I do that, I unfortunately need to run AFK for a bit. Need to hang some laundry and just get something small to eat real quick. So actually, be right back around 10 minutes, I think. Sorry about this. Okay, back. Sorry about that. Let's see. So I want to add some visualizations here and some like this. Let's see, if for fluid point in get neighbors. Okay, let's start with big step duration. Calculate invalid end nodes. Calculate. Here I want to show the minima we're working with. We do m dot finding, no, creating graph, something with graph. Building graphs fluid amount. And then I also want this one here. Let's see how I want to do this. Invalid end node. If it's an invalid end node, actually I'm gonna do but here we're gonna do N and P. And if we add it, let's see here, and this node contains here we just do this. N. Then we calculate final fluid amount. Let's just do it like that. So we go through active, we set it, and we're gonna have serialize field private color fluid test complete color. Okay, that's it for visual steps. What I want to do now is big step duration. We're just going to do that here. And then I want to add small step duration as well. I want to add it here, and actually I want to add it here, and yeah, this one is never going to happen if we do, or is it? I also want to do something like this. Let's see what we get. I wouldn't be too surprised if we have a couple of errors. But if we set small step duration to 0.1 and big step duration to 1, we should never get to a place where it just keeps on calculating, I don't think. Environment is minima threshold fill, great. Probably want to lower this one a bit, 0.5. Maybe even 0.2. Okay, that's good. And if we put it here, we find the minimas. And then we start filling it. I want to fix those colors. What fucking great. I could have changed them while running. Let's see here. Fluid test step 2 color. We want to do a little bit of a darker blue. Invalid end node color, we want to go with red. Something like that. And then fluid test complete color, green of course. Something like that. We find the minima. We fill it. And that's the fill we get. That's an easy test. 0.4. That's a bad one. Or is it? We actually get a puddle there, puddle there, puddle there. I think it's... oh! One sec. Error margin... Okay, let's see. Let's add 7 here. It's a little bit slow here. I wonder if we loop through neighbors we don't want to loop through. Probably. Okay, so this is final fluid amount. Okay. Water 1. Pause 1 sec. 0.02. Fill with water. Okay. Fill with water. Endpoints here. This one is probably, yeah, we're seeing some mistakes here, I would say. But let's see how it handles it. Are we not removing minimas? Yeah, I fucked up somewhere. Beautiful fill, beautiful. Fucked up fill. That's not what we want to see. What's up, E-Dragon, by the way? It's super cool to see stuff you create. So do I think. I think so as well. Love watching visualizations of algorithms. Yeah. Somewhere the algorithm escapes from the prison we're trying to create. What a pain. I think, yeah, I want to visualize one more thing before we can continue here. I want to visualize, let's see here, minimas ordered by descending. This is step 2. Step 1 works. Then we said fluid test active color, and here we want to do, I think we want to do this check again. No. Basically what I want to do, we want to override step 2 color here, but fluid F. P if P is not equal to M, I still want to see the minimas, and I want to see minimas get removed. I think the error we had was that we didn't remove minimas, or I didn't remove minimas. 0.01. Let's do water 0.4. What the fuck? This is a great result, I think. Great result. 0.7. We find minimas, the yellow ones, and we fix this one, and then we fix this one. Then we fix that one. Then we fix this one. Great fucking result, I think. But I saw something I didn't like. I think it was when we filled this one, we actually took a second minima and filled it based on that one. I think that's what I saw. 0.9. This one. We don't. Great result as well, I think. 1. Yeah, here we're fucked. Why? Why? Let's see here. Fluid test invalid. I don't see any with this color. Let me do a try. If we add one here. Yeah, the amount of water we actually add to the minima later on is a bit, but if we do here. Like, what I want to say is we're going to take this minima and then we're going to try and fill this one out. Oh. Ah. Let's see. Yeah, we should get, so for this minima, we should get a point around here. Dispersing it. I think, let's see. Okay, we start with this one. We get there we get end nodes. Weird end nodes. Yeah, I think we calculate here. We should get end nodes. Yeah, okay, something is wrong with the end node calculations. No, it's not. Then we don't actually add what we just add a little bit of water there. That's a little bit fucked. I'm gonna have to debug this one. Then we add a lot of water there. Okay, so what happens? This part works beautifully. Algorithm step 2, we need to fix this one. Minimas, we ordered them by finding minimas fluid amount. So the one with the most fluid amount is first. We add invalid end nodes, or create it. Take the first one, remove it. We take this one and set it in building graphs, okay? We add M to unvisited nodes, and then we take the first, remove at 0. We spawn one of these, and then for each neighbor in P, we do base cost. Oops, sorry about that. And then we try to add it to, or add buildings graphs fluid, new fluid. Yes. So if we succeed in adding the fluid, that means that this one is bigger than the one we had. And then we check if unvisited nodes doesn't contain it, add it to unvisited nodes. If invalid end nodes contains it, remove it from invalid end nodes. And then we spawn fluid test step 2 color. Else if new fluid amount is less than 0, I wonder, it might never become less than 0. Less than or equal to, but fluid cost, this one can be this one should be able to so this I don't think there's nothing wrong with this one. If new fluid amount is less than or equal to 0 and the height of the neighbor a little bit worried about this one. Yeah, that's wrong, right? We want to check if the height of this one let's see here, we want invalid endnodes if yeah, we want to check if this one is bigger than this one, I think. That's not entirely true. Yeah. Yeah, this if statement is wrong, I think. And n has a bigger height than m. Yeah, so it should be like this, but I want to try this. See what we get, but I think we need to add an additional check as well, or an additional condition. That's more like it. the edges as well. This is beautiful. And if we had the worst case scenario, yeah, this is wrong. Or actually, is it? We'll see. We're doing additional checks here, which we probably don't need to do. Okay, I know what's happening here. And this is why we might need the additional condition. This, however, oh, we're so close now. I think I want to check what happens. I think yeah, we don't disperse it quick enough here. But I need to be careful because we don't want to get, like, we could play around with the costs of moving upwards and such in the next step, but that might still yield never-ending results I want to avoid. The problem is this one, or this one of these. Yeah, because now we check, we fill that minima with as much fluid it has, and we disperse it outwards. Invalid end nodes, still not calculated correctly. New fluid amount. Okay, so if we don't have any fluid amount to add, but this might also be the case. When we move upwards, I probably want to avoid that. And also, so first of all, we're not able to add neighbor because we don't have any. We try to add less fluid amount than it has. So we check, is the fluid amount we're trying to add, the new fluid amount 0? If so, and the height of this neighbor is bigger than the height of the minima, then we add it to an invalid end node. I think that's correct. But yeah, something is wrong here. But what? Order by so we get the smallest first. But still with a height that is bigger than the minima. Yeah, I think what's wrong here is that we don't check I want to see what happens if we do abs mathf.abs of this one is less than building graphs error margin. So we just want to add in valid nodes at this stage when we move in parallel. Because we don't want edges. Yeah, definitely don't. Let's see what kind of result we get with that extra conditional or condition. And also I need to remember to fix 0.01 here. I don't care if it disperses into another pool. Yeah, now we try this one. We don't have any, we don't get any edges now. That sucks. Yeah, I think I did a wrong check. We should be seeing it here, 100%. (0.01) N height, M height, yes. What the fuck? Yes. This one should only be hold true for, yeah, if this one is true, this one can't, the second one can't be true. So what we want to compare here is P and N. So the one feeding N, if they have the same height, roughly, and the height of this one is bigger than M height, then we have an invalid point. So this one should roughly disperse here, yes. Let's see. This one or this one should be the first. Yeah, this one is. Let's see. Please. Yes. Although I'm not... Yeah, we want to exit this one earlier if it's possible. But I think, yeah, these are good endpoints. I'm a little bit worried about... I think they are mostly good. Hell yeah. And then we check this one. Hell yeah. And then we check this one. Beautiful. And then we check this one. Ooh, then we check this one. That sucks. Because this one didn't reach this one. Okay, but this is way better. So the green ones are the actual water we get from this worst case scenario. I wonder what happened here. Did this one move? Good result except for... Oh, look at this. It's gonna look beautiful. I think. But what the hell happened here? Here as well. And this one goes on for way too long. The first one to disperse should be the best one, actually, shouldn't it? We always move in the direction of the most fluid. Yep. I want to try that. So for each, let's just add one and do break. Then we break this for loop, but not this one. Yeah, I think it should be okay. So we break this one and we break this one and we move on. Let's try it. Would be amazing. Like, basically what we try and do is we move in the direction that yields us the most fluid. It skeptical, but let's see. What's up, Derek? Looking good, thank you, appreciate it. Yeah, we're getting closer and closer. And yeah, me too. I'm looking forward to creating the water shaders. Yeah, this one is good. I'm a little bit worried about these though. Yeah, it doesn't really work. We have this issue as well. Okay, that's worse. So, if we move in a parallel direction, and the new fluid amount is less than or equal to 0, and the height is yeah, if the height minus the error is bigger than, yeah. Pretty sure we want to do an abs here, although I don't think that will fix anything. I need to take a look at this one again. I feel the issue we're getting is from an unvisited node not being properly removed. Is that it? This one annoys me. We always move in the unvisited nodes ordered by descending, finding minima fluid amount. Yes, that's a big step. While unvisited nodes counts begin at 0. So after we have done all this, found invalid end nodes, we want to do order by descending. This one now we might be able to exit early. We're always moving in the direction of the most fluid. So yes, maybe. Yeah, we can probably skip step 1 in the future. Yeah, so as soon as we find the first one, then we exit. I think. Yes. And if we take a look at this one, we want something like this. Like we want the actual water to be able to disperse like this. I'm okay with that. But we want it to collect. Okay, I wanna test exit early again. And second of all, this. I want to avoid this. It's weird adding water here and getting a pool of water further away than this one with more water. That just doesn't make any sense. No fucking sense at all. And I think it depends on we take the point with the highest fluid. We want to take the point with the highest surface height. We're gonna try that. What's up, Clifford Art? We're just trying to calculate stable state for our water, basically. So I want to try and exit first when we get to one of these again. So when we add one here, we break, and invalid endnodes.count is equal to 0. We can clean this up if if this works. And also I want to add small step duration. We're gonna do small step duration part 1 small step duration, part 2 small step duration, 0.01 part 2 big step duration. One. So if we jump down to this one, the first part, algorithm step 1, it's this one. So we want to do part 1 and part 1. Clifford Art, always something cool and technical going on in this channel. Thank you. Appreciate it. Part 1, let's skip part 1. So we just visualize part 2. And now we should exit early, I think. The fuck? Yeah, I need to double check that one. So let us see exit early now. There we exit, but we add... What the fuck do we add those? Oh, I know. One sec. First of all, algorithm step 1, minima threshold fill. Part 1. Part 1. There we go. So, we should exit early. No, never mind. Okay, so this is a problem. When we exit early here, we might still have unvisited nodes left in this unvisited nodes array. So if we exit early, the last thing we need to do here is unvisited nodes dot clear. And now the first step should be instantly as well, but I want to change environment part 1 big step duration to 1. I want some time to move into scene. Okay, we got it. That's fucking beautiful. Fucking great. Hate this though. We're gonna see what we can do about this one. Ooh. Ooh. Maybe. We get some puddles here as well. Yeah, because we have water flowing here. Yeah, I can buy that. Beautiful. 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 Sorting is a bit wrong though, but actually I want to see one thing. If we add 0.9 here, yeah, I'm not too sure about this one. If we had this much water, we wanted to that's definitely wrong. Oh, we got a minima there. Yes, okay. So here we stop over here because I'm not too sure about this one. So this minima here, or we get, what do we have? Height 0.196, height 0.6. Yeah. So we find a minima here, but the first one stops there. Okay, how can we handle this? Let's see. Yeah, we move up. We have enough water to move up here, but not enough water to... Yeah, we find an... So the fluid we add here is enough to walk up here, but then we dry up around here, which means that we can't add that much water, so we add this height minus this one ish. Yeah, that's not what we want to do. We want to compare but fuck, we move downwards here, don't we? Maybe not. No, we don't. Yeah, what we can do is we could remove this minima because it's already included in a... Oh, whoa, 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 one sec. We could do... If we loop through this one and we find a different minima, I think we want to jump to that one. If that minima has a higher height, or we want to compare with that one instead. Yeah, we just want to change the comparison. Yeah, we do. So here we get to this minima with the fluid amount, and that's a higher minima than this one. So when we compare the height of this one, we want to compare with this one instead. That will fix this issue. I wonder if it will introduce... It will probably introduce... What would happen in this case? If we, for instance, notice this minima, so if we start flowing out from this one, we will notice this minima, which has a higher height. If we start comparing with that one, that's not really what we want to do. That might not be the solution for this. But yeah, I think we want to do this. Let's see what kind of result we get from this. So previously I mentioned that the sorting is probably not that great. Minimas ordered by descending, finding minima's fluid amount. M dot height plus this fluid amount. So we start with the minima where the fluid surface is the highest from the ground, right? Ty Marley, by the way, thank you for the follow if you're still around. Missed it when it happened. Because in this case, we should... that is the question, let's see. Yo, what's up, Fabic? Yeah, that one still sucks. The rest is good though. Environment 1. I want to take a look at this. So if I add 1 here, we pause. Yeah. What if we sort by height only? Yeah, Robert Pattinson, we can go through it. It's different part of the algorithm. Let's see here. Environment, let's see if my variable names are good enough for what they actually are. Fluid test default color is light blue. So that's the initial testing. Yellow is minima. White is active. Invalid end node is red. Complete is green. So the complete state of the fluid is green. And dark blue is just the second step of the algorithm. Basically, that's more like it. And then we start with this one. I want to get to the bottom of this, but other than that, yeah, going by height only leads to weird results like this right here. So if we added maximum amount of water to around here, this one actually is more water flows here than here. That's weird. And more water flows here than here. Yeah, that's definitely not what we want. Fabic, how's the progress going? It's going pretty damn good, I think. Yeah, it does. It does. Same here, Robert Pattinson. I would eat these in a heartbeat. What do you think they taste like? Probably some cola candy-ish. Blueberry. You think it tastes like plastic, but you would still eat them. Okay. Yeah, we have a weird issue here. But yeah. The one with the most fluid makes the most sense. But for some reason, let's see. The beautiful part is that we always reach an end state. I love that. Unless we had an infinite hill downwards, but that's not gonna happen. But this one right here, so we get the minimas with the most fluid. We get this one first. We have a minima here as well, and when we double check, we go through that minima, but then we dry up, so we don't include that minima. But I want to. And actually, one more thing. It's way more costly to walk far at the second state than it is to walk at the first state. No, it's not. It's important that we get further from the start in the initial one. Or wait here. I'd appreciate it, Fabic. the lurk mode, that is. I think I want to do... What's up, Little Miss Murder? Hell yeah you do. Hell yeah you do. This one has less fluid and less height than this one. Do we still get a bugged out visuals here? Let's see. Yeah, we do now because we go the other way. Let's see. Order by finding minima fluid amount. Order by descending. We start with this one. Oh. Oh. Whoa, 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 whoa. I don't see it. Okay, it becomes lower, but then when we add back. How the fuck? How the fuck? Okay. Ooh. Ah, that's... What's the granularity of your terrain height map vertically, I mean? That's a big word. Care to explain it to me? Granularity. Height change, derivative. We don't have a, if that's what you mean, we don't have a limit on it right now, but we will. Vertically. How many times is my height map divided vertically? Like, we only have one dimension vertically. But the height is calculated by a float 8. So a resolution of float 8 is probably the closest I can get. Like, we're not working with voxels here. It's continuous, yeah. As continuous as our floating point number allows us. Okay, this one sucks, because when we test the minimum, we find this minima only because we disperse water in this weird direction. So this one actually gets more filled because all of this water moving here, which is weird. Yeah, yes, we're treating the water the same way we are height. And then when we check this one, we don't check in a big enough area to include this one, because we find end nodes, so we stop. Then we fill it, then it's time for this minima. Yeah, we want to make it. I don't like to fix it like this, but if we fix the initial spread of the water, we will fix this. Like, when we use the hose or the bucket of water, we probably don't want it to spread this good on even ground. Maybe at a cost, a bigger base cost. Like, if we do it environment base cost for finding minima base cost, I don't know, 0.2. We want to add a negative. We want to add a cost for going negative as well. Fucking hate this. What's up, Black Arrow? But actually we would probably get water like this. Yeah, that's not too bad. This one's... This one... No. This is okay, I think. Yeah, we get a pool of water here and then it goes down. Yes. I wonder what happens if we do final fluid base cost 0. Beautiful. Yeah, this worst case scenario, I would say. Or actually, no. This one is the higher one. It will have a small waterfall going down there and a small waterfall going down there. Not realistic at all, but like how I want it. Okay, I think would love some more edge cases, but this is good. We're probably gonna run into a scenario where it doesn't work. That's for show. Whoa. Yeah, like now. I wonder, however, we can have multiple... Yeah, I think that's my mistake. We can have multiple fluid simulation going on simultaneously, and they will fuck with each other because they will use the same... Will they use the same? Okay, this one is interesting. What's the reason for this one? We're finding an edge. We're not finding the correct edge, I suppose. We're not finding any edge at all. Yes. Robert Patterson, are your simulations update on Unity update? No, we do it with coroutines. Yeah, we don't So the case we get here is invalid end nodes is not bigger than 0. So final fluid amount is equal to building graphs fluid amount Yes, and this only happens when I removed the cost for moving horizontal for the final one, and that one screwed me over. That's why we're seeing this. Robert Patterson, you could update all your simulations from one place in the order you need, passing data you need to the next thing. I'm not entirely sure I follow. So we only do it in a coroutine right now because we want to visualize it in a nice way. The idea is to pass off the simulation to a secondary thread in the end, so we can and it will calculate the multiple different states, and then we will just pass them back and do some visual magic based on it in the end. So coroutine purely here for debugging. Quitting a coroutine when I want, that would be nice during debugging, because then we could quit it here and we could just probably do a little bit of a hack. But let's see here. Yeah, we don't find any end nodes. That sucks. So if we don't find any end nodes, I think we just want to do this, honestly. Let's see here. Else okay, we don't find any invalid end nodes, but that's because we don't... Yeah, we decrease the amount of fluid even on a... Ooh, 1 sec. Yeah, we're gonna fill this one differently. Let's see here. Or... I think it's because... What the fuck? Okay, if we don't find any end nodes... Yeah, we need a fallback. I think we can do it like... I think we can do it like this. Highest point, if p is not equal to m, if p dot height is bigger than m dot height. Oh, whoa, 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 whoa. Is equal to p. Guess we could just save it as a float as well. And finally, when we calculate this, if we don't have invalid end nodes, we do else. Highest point. We don't have any end nodes, so we take the highest point we reach with this water. I wonder. That's not what we want to do. Yeah, the error will still be here, I think. Or And the rest of our algorithm fixes it, I think. The white dots, let's get to the bottom of those. Yeah, okay, so the problem here... Yeah, here we have a problem. Ah, we don't. Here we have a problem. Fuck. Am I okay with this? But the problem here is that... yeah, we find a cheaper way. The first iteration finds a way towards that point that is cheaper. Finding minimas. How? Minimum base cost. Upwards multiplier. Yeah, okay. This one... minimum base... no. What the hell? The second iteration should always be cheaper, but we start from a different point with less fluid. We probably want to be extremely tight on the water amount we send in the first one. I was still gonna get it. Okay, it's because we move... I'm okay with this one. We move... yeah, we find this one first because the path to it is cheaper. would probably be okay with this as well. Yeah, I would. Ooh, this I would... Actually, would I? I wonder what kind of result we get if we do if we go with a little bit more realism, add building graphs, but and just do height order by. So the one with the smallest height first, that's the one we fill first. Because that's where all the water should pool up, I suppose. So begin with that one, and then we take that one. And then we do a lot more. I think this is visually the best result, but there's a lot of extra calculations here. And the blue ones here in the middle, they don't have... They already have more water, so we don't fill them the second time, I think. I honestly think this is... The end result is the best from doing this. But we want to fix this one. Yeah, but if we do it like this, we need to be a little bit more aggressive by removing duplicated minimas. how we order them weighs heavy. Because like if we order them by fluid amount, 1 sec. Yeah, that's true. We get Minimas with barely any fluid whatsoever. So we can't purely sort them by height. But if we do order by height, order by first of all, descending. Let's just do this, see what kind of result we get. Can't you queue or order by first and then order by? What am I missing? Oh, fuck it. Let's see here. Order by 2 values. Link C#. It should be order by, then by descending. There we go. I thought. And if we just do then by, what the fuck? Compare. Oh yeah. Oh, what the fuck. It's getting late. What do we want here? We want finding minimum fluid amount. That's what we want to do. Order by height first. So lowest height first and then by fluid amount. Let's try it. Way worse. This one yields the best result, I think. Order by. But sometimes results that aren't that great. I wonder. I wonder if we want to do some minima trading, basically. Derek, you think tomorrow you will be able to start working on the shader or still got a ways to go? I want to be optimistic, but there's a slight possibility that we might start working on the shader tomorrow. Like, if I just lower the bar a tiny bit, tiny bit, we have an acceptable state here, acceptable fluid solver. We never reach unreachable states, and we fill up the cavities mostly in a good way. But so even though the result would be good now and I would move on, I would first reiterate this method. I think there exists, first of all, we want to rewrite it as a non-coroutine, clean some things up and stuff like that. So I won't start with doing the water shader tomorrow, but there's a slight chance I might start it later on in the stream, if that makes sense. So let's see, order by descending. Yeah, so this one, for instance, when we I guess this is okay. Yeah, the player can pretty much decide how he or she wants his or her water to flow. And by that I mean, like, if we have lakes and rivers, we can select, as long as it's a minima. Are we gonna get a crash here? No, we're not. Oh, whoa, 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 whoa. Okay, the minima. This one finds an end point here. Why? But that doesn't make any sense. What the fuck? New fluid is less than 0. Yeah, that I get, because we're moving at we're moving from this one to this one. Same height. Mm-hmm. Mm-hmm, mm-hmm, mm-hmm. And that's because we exit on first one. If we didn't exit on first one, we would move from this one to this one. Would the end result be much better though? I don't know. It's not that bad because the like when we go to the other minima later on and start running from that one, it fixes it. Maybe it's preferable to exit early on a end node like this. This is good enough, isn't it? Probably gonna find cases later down the road. Yeah, so it's gonna be very important when this method is rewritten that we add comments and stuff, make it make sense. Oh no. This one right here is because I think it has to do with final fluid amount. We're doing this. And this could be a little bit above 0. Would be my guess. Or 0, actually. Final fluid amount 0. Yeah. And we add it here. Yeah, that sucks. We could remove that case pretty easily, but we want to do it in a nice way. We could just check if this one is within error margin of 0. We don't do this. But yeah, so we find a minima that won't be filled with water after the second check. Let's see, how did we get this? We start stepping vertically and we add a loss to it, so we don't walk that much. The place where we end has the same height as our start position. That's a little bit weird. But actually it's a minima. In this case I would like to fill this one up just a tiny bit. So we get 0.2. So what, we fill this one up with blue. We don't find, yeah, we fill it up with blue. We don't find an end point, so we do highest point, and the minima is actually the highest point. It's all thanks to us exiting early, I think. Invalid end nodes. Yeah, we can do that in a cleaner way, I think. want to avoid the minima itself becoming its highest point. So like in this case, what I would like to find, I would like to find the lowest point we can't climb. So basically I think we still need this check. Yo, what's up, Raiden? So this one fails. This one fails. Yeah, we can't add any more fluid. This one also yeah, this one also fails. If n dot height is bigger if n dot height is less than lowest unreachable point dot height, then lowest unreachable point is equal to n height dot just n. If this one has a height that is less than the lowest unreachable point, set that one there, and then we do yeah, Raiden, we're gonna quit it soon. I don't feel strong right now. What's up, XXVO? Yeah, I think it is pretty complicated. Let's see here. Now we have a lowest unreachable point and a highest point. And we wanna do... What do we do? If I think we can do like this. Well, one sec, what am I doing? Yeah, so down here we want to use something. Final fluid amount should be equal to mathf.max of this one and could this be it? Fuck, I don't know, probably not. We'll see. I named my own channel name with a correct punctuation, which is XWOA. Try to not mispronounce people's names. Then we get this, and we get this. What did we have? 0.2. Fuck. Okay, that was not it. I think I went a little bit too quick there. Or did I? Max of highest point dot height minus m height. That gives us 0. Lowest unreachable point height. Minus m height should give us some fluid. We end up here, right? Do we? Okay, Fabic, I think we will end on that note, but don't hold it against me. I'm gonna do a try here. Maybe Maciej Fabijanski. Hopefully not too bad. This one is a weird one. This last issue here. Thank you, appreciate it. Yeah, I think we're gonna end on that note. So tomorrow we will hopefully be able to settle this one pretty quickly. And then I think we're gonna move on to representing the result of our simulation as a mesh. We have already started that, but we're gonna do it again. We're gonna finish it. And when we have that mesh in place, that's when we can start with the water shader. XWOA. Okay, I will try and remember that. But yeah, I'm... let's just say this. I'm very happy about the progress today. Yeah, thank you, Fabik. But I'm totally drained. I have like 0 energy left. But yeah, let's pick it right up tomorrow. So as always, I just want to say thank you everybody for watching. Very much appreciate it. Hopefully I will see you tomorrow, and have a great rest of the day. Peace.